So I'm here at night. I couldn't sleep, and so I decided to come back to school and make a video because I was worried that people didn't know how to do tables. Let me turn the lights on. I'm trying to keep it on the down low that I'm in here. They always worry about us being here late at night. Uh, let's go ahead and freeze the problem right now. So pause, and I want you to pause and look at this table, look at these questions, and answer them all, and then I'm going to go through the answers one at a time. I know you're lying if you don't pause it. Pause it. Now. Okay, let's go through the answers. Coming off your pause. Looking at this table, first of all, analyzing the function. When we're analyzing the actual function value, we just want to pay attention to where it crosses the x-axis. So there's a place right here is a 0, and there's a place right here where we have a 0. So we know we have 2 zeros. Minimum number of zeros is 2. Okay, I'm going to answer that one first. The derivative must equal something on the interval. Okay, this is a mean value theorem question. So the average slope, if this is continuous and differentiable, which it is, the average slope has to equal the instantaneous slope somewhere. So we have 2 points. We have the point -3, -5, and we have the point 5, -4 that represent the whole interval. So -5 minus -4 over -3 minus 5. That would be -1 over -8. So that's 1/8. Somewhere the slope has to equal 1/8. We don't know where. We can check and find between each point, but we're not doing that. Okay. List the critical numbers. Important you know the definition of critical numbers, where the derivative is 0 or undefined. So x equals -2, x equals 0, x equals 4, critical numbers. List the extrema. Some people think that these two are the same question. Extrema happen where the derivative is 0 or undefined, but we have to test it. Okay, so there's 2 ways to test it in the table. Go to your first critical number, which is at x equals -2. That's concave up because of the second derivative. It also goes from a negative slope to 0 to a positive slope. So whether you test it negative slope, 0, positive slope, or concave up at -2, -7, we have a relative min. Notice I went and put the coordinate back in, -2, -7. Sometimes it asks for the x, sometimes it asks for the whole coordinate. And then we go here, concave down, so it's a max. Also goes from positive to 0 to negative on the slope. So, we have a maximum at x equals 2. When x equals 2, y equals 1, we have a relative max. Third one, slope goes from negative to 0 to negative. Concavity doesn't work, so that test doesn't work. So at x equals 4, we have a neither. All right, let's go down to the inflection points. Inflection points happen where the second derivative is 0 and the concavity changes. So we have an inflection point possibility at x equals 2. This is silly right here. Sorry. Can't be right. Check, check. Critical numbers were -2, 1, and 4. Still checked at the right place. At 1, we had a relative max, sorry. And the point was 3. Maybe you caught that. If you're paying attention, you can tell me about it in class. List the inflection points. So possible inflection points are at x equals 2, x equals 4. Concavity changes from negative to 0 to positive. So at x equals 2, we have an inflection point. When x equals 2, y equals 1. That's an inflection point. And concavity changes from positive to 0 to negative, so at x equals 4, we also have an inflection point. And the y value there is negative 2. Often those are shelves. We don't really know enough to see what that looks like. So our critical number that wasn't a relative extrema showed up again as possible inflection points and ended up being an inflection point. Minimum number 0 is already answered. Y-intercept when x is 0. 0, 2, or y equals 2. Is there an absolute max? Is there an absolute min? Is this a closed interval? Is it continuous and differentiable? Closed interval, continuous and differentiable. Then that meets those conditions. And the next thing is it going down and up? If it's not just a horizontal line, the time you wouldn't have a max and min would be something like this. Is it going down and up? Yeah. So if it does, then you know you have an absolute max and min. You don't need to find them. So yes, yes. Those are often parts of multiple choice questions. So hopefully you can sleep now that you've watched this. I know I need to go home and go back to eat breakfast or something productive. Bye-bye.